Normal distribution, unit 4, applied mathematics class 12, we are going to discuss. Already we have done what is random variable and its probability distribution, binomial and Poisson, both the distributions are done in the past few sessions. This is on normal distribution. Why this normal distribution is required? I mean, derivation of formula obviously we are not going to do here, not required also for all applied mathematics students, but why Poisson distribution, that you why normal distribution, that you need to know. If the number of observations, I mean number of trials is indefinitely large, number of trials be n is tending to infinity. Okay, this is one condition, and the other condition is neither the probability of success, neither P nor Q is very small. PQ has definite value, but number of number of trials tending to infinity. We apply normal distribution in those cases. Okay. For example, if in a locality 2 lakhs people are there and people staying over there, say age group 20 to 60, you need to keep a record of their heights or their weights. Obviously this cannot be a discrete distribution. The values of their heights or weight change over a wide range. So better you keep those observations within two braces. I mean within an interval A comma B. What you have seen in case of binomial and Poisson distribution, those are discrete distributions. Every point has a definite probability and then we calculated expected value, standard deviation, variance, all these things. Here everything will be determined, but remember number of observation large. For example, I took 2 lakhs, 5 lakhs, it may be 2 crore, more than that. Okay, when n is tending to infinity and PQ has definite value, that distribution we refer as normal distribution, which will help you to calculate the probability of those events, trials, whatever you say. This is Gaussian distribution, continuous probability distribution that is symmetric about the mean. This point is the mean. Symmetric about this, you can see that if we take this one as y-axis, this one as the y-axis, then it is symmetric about y-axis, and this is the mean value. Mean is 0, but it is not 0 always. Mean can exist if it is not a standard normal curve. For a standard normal curve, it will be 0. This was discovered by Carl Friedrich Gauss. Already I have mentioned about this mathematician, and this person is master of many fields of science and statistics. This is widely used in natural and social sciences. Why it is preferred? There is no preference. It depends on the demand of the situation. We need it when distribution of sample is such a manner that sample size becomes very large. Whatever the shape of the population distribution, that we don't care, but whenever sample size is very large, that tending to infinity, we use the normal distribution. It is suggested by central limit theorem. It has simplicity and natural occurrences. That height, blood pressure, weight, in those cases we can use normal distribution. And it has some unique mathematical properties, making it easier to work with for hypothesis testing and confidence interval. This we'll discuss in hypothesis testing or statistical inferences chapter. Right now we'll remain silent about that part. Okay. Now I have to discuss what is normal distribution. Step by step I am going to explain. The normal distribution is given by the probability density function fx equal to 1 by root 2 pi sigma e to the power minus x minus mu whole square by 2 sigma square. Okay. The value of x is greater than minus infinity, less than infinity. Okay. Mu is known as mean and sigma stands for standard deviation. Both are positive. This is standard deviation. Okay. The value of root 2 pi, if you calculate by putting pi equal to 3.14, it is approximately 2.5066, and this value of E, I have told you earlier, approximately 2.7183. Okay. If a random variable follow this probability density function, it is said to follow normal distribution. Okay. It has mean mu and variance sigma square. So sometimes we write this distribution, if we denote the random variable by x, we write it this manner: n mu comma sigma square. Okay. Sigma square stands for variance. So in this probability distribution of normal distribution, whatever I told you, the graph, if you plot, it will be symmetric about y-axis. It is bell-shaped and symmetric about the line. Initially, if you don't consider the standard normal distribution, it is symmetric about this line. It's like this. Okay. Obviously, fx taken this manner and x is taken this way. Okay. It is a bell-shaped curve, and this thing we are considering x equal to mu. This is not origin, just a line, x equal to mu. It is symmetric about that line. Okay. Then if we fold the curve about this line x equal to mu, then left part equals with right part. This is symmetry. Okay. The value of x increases numerically up to this point x equal to mu, then its value gradually decreases. Okay. Now this curve whose equation is, if you have taken x this way and y this manner or fx this manner, I showed you the PDF is 1 by root 2 pi sigma e to the power minus x minus mu whole square by 2 sigma square x greater than minus infinity less than infinity. This is not standard normal curve. To get the values quickly, we need to use standard normal distribution. Okay. For that, we need to make a substitution on this. Let us make a substitution z equal to x minus mu by sigma. You can take this one capital X, whatever. This x is actually value of x. One value of x we have taken here. So this x is actually, if you cross multiply, is going to be equal to mu plus sigma into z. Under this transformation, if you take z equal to x minus mu by sigma, this curve is changed to, x will be changed in terms of z. This will be 1 by root 2 pi e to the power minus z square. Here random variable changed to z. Z has a value which is equal to small z. We are taking that. So if z equal to 1 by root 2 pi e to the power minus z square by 2, and this z, it has variable value. This is also lying between minus infinity to infinity. Clear? Understand? So this bell-shaped curve, if you plot it, then this is going to be like this. But this doesn't look symmetric, so this part I will not take. I am drawing the curve once more. We have to make it symmetric. Almost. If we shift the line towards right, then it will be fine. Okay, just shift it towards right. For this distribution, the equation is this: if z is equal to 1 by root 2 pi root over e to the power minus z square by 2, and here z is equal to 0. These are the points. Z is equal to 1, 2, 3 like this, and here minus 1, minus 2, minus 3 like that. Okay, this is 1, 2, 3. This part is minus 1, minus 2, minus 3. It's like this. And z is in between minus infinity to infinity. It can take any value between them. This standard normal distribution curve had some advantages. Here, if you write from this to this, its value of mean is equal to 0. We have taken it here, and sigma going to be 1. Sometimes we write this one as, by taking the random variable z, is n0, 1. It means mu equal to 0 and sigma equal to 1. Advantage of this is that it does not contain any other parameter. You see, only variable is there, 1 by root 2 pi to the power minus z square by 2. But you cannot ignore this thing, it is hidden over there. But this particular distribution has no other parameter, only variable z is there. And this, if z you know, it is probability density function, it will give you the probability. That probability can be obtained with the help of the tables. Table in many books given different manner. This is one way. Table given on the right side of 0, all these values. The value of 0.0, 0.1, from 0 to 0.1, how much value they have given? 0.1 to 0.11, what's the value given? 0.2 to 0.208, what's the value it is given. So when you are finding area of this curve, this will give you probability. That I am coming one by one, step by step I will tell you. Okay. Suppose you are asked to find probability between these two coordinates 1 and 2. That will be represented by the area between 1 and 2. But before that, I need to say what is the area under standard normal distribution curve. The area under standard normal distribution curve, we are saying that this area bounded by the standard normal curve with the z axis or with the x axis here. Normally you take this one x, but here the variable is z, that's why it should be stated in terms of z, and fz this way. Area of this whole thing is going to be equal to 1. Okay, application of integration is there, that you don't need. And this area 1 means probability between minus infinity to infinity. If we change in terms of probability here, that is going to be 1. Okay, so if we say that z is greater than minus infinity, less than infinity, this probability we want to write, this will be equal to 1. Total probability 1, that is true in this case also. Okay, total probability is 1. Once more I tell you that the table confusion, let me make it clear. This table you can see, these are given, these have collected from NCERT support material. You need to remember this table, otherwise confusion will arise. Right now you practice from any book, any table, but remember finally the values in your board examination will be given in terms of these two tables. Okay, so if we say that probability, total probability is equal to 1. Total probability means area under the whole curve. Then what the table stands for? The table will give you the value of probability partially. Partially means this z-scores table. Probability z less than equal to z, it is given directly in the table. This point may be anything. Suppose this point is minus 3.3. Probability less than minus 3.33 is going to be 0.005. Suppose this point is minus 3.45. You see, if it is minus 3.45, just a minute, let me reduce it. Minus 3.45 in the table, where does minus 3.45, that you have to take care. Minus 3.4 years, 3.45 is 0.003. So that probability z was replaced by minus 3.45, probability up to that, I mean from minus infinity to that minus 3.45 is going to be this thing, 0.0003. Okay, this table provided in NCERT support material. You must go through this table once. Is that clear? You understand what I say? Just a minute. Yeah. So directly from the table you can get any probability. Number of then this one, if we take z as a point on right side, what does it mean? I mean up to this z given directly. The previous table I told you, there is no contradiction between these two tables. You have to notice that whether they are giving probability between z equal to 0 and z equal to something like this or not. Okay, so if it is between 0 and z, then this table. You must see the statement given in the table, then you proceed, otherwise you will be wrong in every step. This I am telling you. Clear? So here this one will give you this area. This table is between probability of 0 and z. Between z equal to 0 and z equal to 0.5, the probability is 0.1915. Z equal to 0 and z equal to 0.58, then probability is 0.2190. Got it? No confusion. There it is given, NCERT support material they have given minus infinity to z directly. But here it is given between 0 and z. So they can give you any information, but if you keep this concept in your mind, that total probability is going to be 1 under this curve, then the problem is solved. So before we start actual problems, let me discuss some properties of it which will help you to solve the problems quickly. You see this standard normal distribution curve, okay? This I have drawn by using a mathematical software. This is representing the graph of Z versus FZ. Okay? Z versus FZ. What FZ stands for? FZ stands for 1 by root 2 pi e to the power minus z square by 2. Z is between minus infinity and infinity. This graph is there. Okay? Now, suppose we want to find the probability between, I'm just discussing a few cases. The problem will be simplified for you then. If you want to find, suppose let Z1 greater than 0 and you want to find probability of this event. Z is greater than equal to 0, less than equal to Z1. What does it mean here? First, let me draw the area over there. Z1 is arbitrary. It may be anywhere. This is say Z1. Between 0 and 1, this area will tell you the probability between Z equal to 0 and Z equal to 1. Clear? But if you see that, how will it solve in the table given in the other books? No problem. You should remember that when they have given up to Z1 probability, from there if you subtract the probability of this portion has probability 0.5 and this portion has total probability 0.5. If minus infinity to Z1 given, from 0 to Z1 you can find by subtracting that value from that value 0.5. If you subtract, then you will get 0 to Z1. So it is relative. Whatever table given you can find. If it is given the table from minus infinity to 0, from minus infinity to Z1 directly, then from there you will subtract the probability of the left portion. But meaning is this, between 0 and Z1 if you write, then probability is equal to this area. Okay? Now this is one property. Property 1 I have written there. Okay? And let us go for the next one. Property 2. Property 2, actually this is just understanding of standard normal distribution curve. If you want to say, I'm just, before I proceed next one, I tell you, if you want to say Pz less than equal to 0, symbolically Pz less than equal to 0, this will represent the area on the left side of origin. This is 0.5 and Pz greater than 0, this is also 0.5. Okay? Now, if you want to write, say, probability of this event, Z1 less than equal to Z less than equal to 0. How to write this? Minus Z1 to 0. Minus Z1 to 0 you are going to write. Minus Z1 to 0 means minus Z1 lies here. Okay? Minus Z1 to 0 means this area. As it is symmetric about this y-axis, I mean z axis, so area between minus Z1 and 0 is same as 0 and Z1. This portion has the same area as that of the left portion. So this thing is going to be equal to P 0 less than equal to Z less than equal to Z1. Clear? Hope you have understood. Let us discuss a few more properties. Number 3. Third one, I am saying that P Z greater than equal to Z1. Every time if you draw a diagram, it will be easier for you to get the idea. So, standard normal curve, if you have drawn here, Z greater than equal to Z1, this portion is Z1. So, this portion, probability of this portion greater than Z1 required. It means area of this shaded region. So, Pz greater than Z1, you can write, this is, you write not equal to, just greater than. You can write this thing equal to, on the right side, what is the total probability? 0.5. 1.5, we are subtracting probability from 0 to Z1. So 0.5 minus P Z greater than equal to 0 less than equal to Z1. Clear? I hope you understand all these things. And then suppose you have to find for Z, just let me draw another one, let me explain. For this one, suppose they have asked you to find P Z less than equal to Z1. Z less than equal to Z1 means Z1 lies somewhere like this, Z1. So on the left hand side of it, everything you have to take. So this is what? Probability up to 0 plus probability from 0 to Z1. Probability up to 0 is 0.5 plus probability between 0 and Z1. This will do from the table. Clear? Now suppose you want to find number 5, I am writing here. Suppose you are going to find P Z1 less than 0 and P Z less than equal to Z1. Z1 lies here. You want to find probability Z less than equal to Z1. This is nothing but we have to get this thing, no? Z less than equal to Z1. It's a Z less than equal to Z1. If it lies on left side, then you see this is symmetric. So this Z1 lies on right side also. So Z less than equal to Z1 means P Z greater than Z1. So this I will get from 0.5, this area you subtract 0.5 minus probability between 0 and Z1. Clear? Alright, you have understood? Because Z less than equal to Z1 and Z greater than equal to Z1, there is no difference. If Z1 lies on left side, this is minus Z1 then actually, and this is plus. So left side of Z1, whatever area there on the right side of Z1, same area will be there. Is that clear? Okay. Now let us solve few problems from here. The idea will be clear. And before we start solving sums, I would like to remind you this inequation. Mod Z less than Z1 or equal to whatever. This implies Z greater than equal to minus Z1 less than equal to, just to avoid confusion, I just remind you. Reminder, mod z less than z1, it means z greater than minus z1 less than z1. And mod z greater than z1. What does it mean? This implies that z less than equal to minus z1 and z greater than equal to z1. If you remember these two concepts, which you've already done in inequalities in 11 and 12, then it will be very convenient for you to calculate the probabilities over there. Okay? Now I am giving you just a few sums based on this concept. Okay? Just question is given this manner. Say Z is the standard normal, variate. Okay? You find probability between, find P 0.53 less than equal to Z and less than equal to 2.03. Writing a few more, you have to find P Z greater than minus 0.81 less than equal to 1.13. Okay? Then suppose we want to find one modulus one, you take P mod Z less than equal to 0.25 from table only, use of table, and P greater than equal to this, less than equal to 1.96. And the last one, find P mod Z, P of mod Z greater than equal to 1. Direct application of the concept we have learned, and I am making you habituated from this table for the moment. That is, in future we may take the other table also. Okay? So telling you to take this one. Okay? Use this table here. You are going to use this table there in those sums. Just a minute. Yeah, for these problems. Just see the table and find the value. Try once, then I am doing it for you. Definitely I will solve. Just check the table, and I hope all of you are sitting with me with your pen and pencil. So you need to find probability of this thing between 0.53 and 2.03. So one thing, symbolically this probability we can express in terms of A false. Okay, not required right now, you just check. It is 2.03 and 0.53. 0.53 where? See in the table, 0.53, it goes there. So it is 0.2019 up to 0.53. Wait a minute, I just shift a bit. Yeah. So this you write up to 2.03, whatever the value. From there 0.53 you subtract. Something like this. In standard normal curve, it's like this. This is 2.03. You are going to find this area probability. This is the area between 0.53 and 2.03. 2.03 area 2.03. This part is 2.03. What is its value? 0.47. 0.53 you check. 2.03 you write first. 2.4783. From there you subtract 0.53. 0.53 is which part? 0.2019. So the value you just subtract going to be 0.2769. So the value lying between 0.53 and 2.03, if Z lies here from the table, we can get it nicely. Okay. Now we have to find P between these 2 points, minus 0.81 and 1.13. How to find? If you plot the graph here, (1.13) lies here, minus 0.81 lies here. So you need to find this area. Graph symmetric. The graph is symmetric about this axis, FZ axis. So don't you think that minus 0.1 to 0, the area will be equal to 0 to 0.1 area? Am I correct? Area from minus 0.81 to 0 equal to area from 0 to 0.81. So how do you find this area? This area I will be writing area of this plus area of this. But area of this can be taken on right side also, between 0 and 81. So let us write the statement here. This is equal to area between minus 0.81 to 0 plus 0 to area between 0 to 1.13. But area between minus 0.81 to 0 means area between 0 to 0.81 plus area between 0 and 1.13. Area between 0 to 0.81 you know very well. All of you know this. Just put the value. The value is 0.81. You just check. Kept it open for you. 0.2910. This plus area between 0 and 1.13. 1.13 is there. So it is 0.3708. Alright. You just add these two. Approximately it's coming 0. It's coming like that. Clear? Hope you have understood. Actually, this numerical problem when you are solving, you will face this kind of situation. How do you find the area between area mod z less than equal to 0.25? Mod z less than equal to p 0.25. How to find it? This, I reminded you, this is equal to p z greater than minus 0.25 less than 0.25. Again by symmetry, what do you observe? If you go by symmetry principle, when they are asking area between minus 0.25 to 0.25, this is say 0.25. When they are asking the probability between these 2 points, it is actually this area. But area on the left side of y-axis, I mean minus 0.25 to 0, whatever area there, 0 to 0.25, same area. So can't you write this thing as 2 into area between 0 and 0.25, which is nothing but, you just check 0.25 area, 0.25 is 0.0987, 2 into 0.0987 coming 0.1974. Alright, hope you have understood. The next problem I have asked to find the value of z greater than equal to, next part I have asked this one, how to find p, then we will go for practical application. Z greater than equal to minus 1.64. It is your advantage if you draw the diagram and write the value once what you understand. So let us draw the curve. Again, standard normal curve. And the curve will like this: 0, 1, 1.64. This is 1. This is minus 1. Minus 1.64. It lies here. Minus 1.64 somewhere like this. Say this is minus 1.64. Your problem is to find p z greater than equal to this, means this whole area. How to find it? This you need to simplify. This you can write. Total probability is 1. Total probability, you know, 1. Isn't it? So z greater than minus 1.64 means this whole probability is required. It is actually, this you can rewrite. This is actually 1 minus p z less than 1.64. Just try to understand. No, pz less than minus 1.64. pz less than minus 1.64. pz greater than equal to that means 1 minus pz less than this. Now pz less than minus 1.64 and greater than minus 0.64 has the same value. So this you can write 1 minus, once more I am writing this thing, means p z greater than 1.64. p z greater than this means total probability on the right side, 1.64 is here. Right side of this, it means this part probability will be 0.5 total probability on right side. From there, Pz less than 1.64 you find. So it is 0.5 plus Pz less than Pz less than 1.64. 1.64 it lies where? Just check 1.64, 0.4495. 0.4495. So this is going to be 0.9495. Got it? Have I made it clear? Was I able to explain it to you? Hope you have understood. So now let us solve some practical problems on it. Okay? We are going to discuss some practical problems because this is a very practical topic. I told you normal distribution is, I can't say that it is more important than binomial or Poisson. They have different uses. In that case, Poisson normal distribution you can use, but it will be very, very much calculation based. Okay, so you should not go for it. But most of the practical cases, normal distribution is in use. Clear? That is not binomial or Poisson. It is normal. Let us go for this. Number 1. The mean score of a test is 70 with a standard deviation 10. Okay? What percentage of students, what percentage of students scored between 60 and 80? We will go back to that value of Z because the table is given in terms of standardized value of Z. Okay? So for answering this question, we need to use that Z equal to x minus mu by sigma. This given as mean given as 70. So x minus 70 by 10, isn't it? They are given that scored between 60 and 80. Given that Z greater than Z1 less than Z2. Z1 you have to find. Z1 equal to what? X lying between 60 and 80, that is given. That is not value of Z. We need to get Z. For x greater than 60 less than 80, Z1, you replace x. Okay? Or you write, you subtract 70 from two sides. This is greater than minus 10, less than 10. I need this portion, no? So x minus 70 by 10 is greater than minus 10 by 10. This implies this is Z. Z greater than minus 1 less than 1. So for x greater than this Z lying between Z greater than minus 1 less than 1. In standard normal distribution, you have to find this thing. This is say minus 1 and this is plus 1. The standard normal curve, if you plot. So you need to find this area. How to find it? How to find this area between -1 and 1? You know area between 0 and 1. Area between 0 and 1, that table I told you. That area between 0 and 1, if you go through the table, just a minute, if I can bring, I'll try it here to bring it. Just let me check. Yeah, it has come. I make it shorter so that I can brought it anywhere. This can be brought anywhere. So this probability between -1 to 1 will be between 0 and 1 and its double. So when you are writing P z greater than -1 less than 1, this implies twice P z greater than 0 and less than 1. 0 to 1, what is given here? You just go through the table. Just check the table. It is given here. 0 and 1, it is given 0.3413. So this is going to be 0.6826. Clear? But the question is different. What percentage of students scored between 60 and 80? Just convert this one in percentage. Required percentage will be equal to 68.26. Okay? You understand? This is a practical application. This is required by a teacher, administrator. The director of the academy has asked you find this. Mean score of the student is 70 and standard deviation 10. On this basis, you tell percentage of students scored between 60 and 80. Okay? This parameter was settled by someone and you have worked on it. So your answer will be 68.26. Let us go for second one. Okay? You just read the sum, I will explain. Company employee heights are normally distributed with a mean of 170 and standard deviation 6. Okay? What height separates the tallest 10% from the rest? This you need to think. This problem you need to think. Company employees' heights are normally distributed with a mean of 170 and standard deviation 6. What height separates the tallest 10% from the rest? This is the question. So here you are going to find because they say it separates the tallest 10% from the rest. So rest is what? Rest is 90%. And from Z table, 90% means probability is 0.90, just you have seen in the previous example. Okay? From Z table, you see the value of Z in compared to this probability. The table is with you. In the table, you just check what value correspond with 0.90 over there, that Z value. This we have to find. Okay? Just a minute. It's mixed up over there. Just a minute. This I'm not able to separate. Just erase it. This time you write z equal to x minus mu by sigma. Okay. What is mu given here? Mu is 170 and sigma how much? That is equal to 6. Clear? The value of sigma is given to be equal to 6. You need to find the Z score corresponding to 90th percentile from the Z table. Okay? So then only you can find the value of x. They asked in terms of x. See, this thing is reduction. This thing will be reduced, but original one is x. So x minus mu will be z into sigma. So x will be what? Mu plus z into sigma. This mu is 170 and from the table that z value corresponding to percentile 0.90 from the z table, 0.90 from the z table, if you find this is equal to 1.28. This multiplied by 6 by my calculator, it is giving approximately 177.68 centimeter. Okay. Go through the next problem. IQ score are normally distributed with a mean of 100, standard deviation 15. What percentage of people have an IQ less than 85? This is very easy sum. You need to find Z. Z equal to x minus mu by sigma. That Z you find. Z equal to 85. It is given 100. That divided by 15, its value going to be minus 1. So required to find P Z less than minus 1. Z less than minus 1 you can get directly, or using the table I have used. If you go through by the table provided by the NCERT support material, that Z less than minus 1. Minus 1 is where? Just check. This is minus 1. Here it is given directly. Here it is given directly. It is how much? 0.1587. Can you see that? It is 0.1587. If there is no contradiction, I told you, you can get it from new table, from the old one, whatever I have given. It is 0.1587. The material provided by NCERT has some advantages. You can get the Z value directly from there. So your answer will be required percentage. They asked you the percentage. Required percentage is going to be 15.87%. Clear? Now the question is, average weight of certain species of fish is 200 grams with a standard deviation 25. What weight is like previous one? Okay. Like previous sum I have discussed already. Let us do this one. Marks of class of 100 students are normally distributed, mean given, standard deviation given. How many students scored above 60? If you want to find, you need to get Z. What is given? X and mu, that you will write. That value of mu is 50 and mu is given 50. Standard deviation sigma is 5 and x is greater than 60. So first you calculate For x equal to 60, what is the value of z? It is going to be 60 minus 50 by 5. This is equal to 2. You need to find pz greater than 2. Pz greater than 2, if you go through the table, it is going to be 0.0228. Okay, this is actually 1 minus p z less than equal to 2. Okay, that table you put 1 minus 0.738, it's coming 0.0228. Several ways are there, you can find it. Z greater than 2 you can find by this method also. If z is greater than 2, you need to find this area which is equal to 1 minus p z less than 2. Hope you have understood. Sorry. This kind of problem also they ask in board examination. The light of bulb is normally distributed with a mean of 1000 hours and standard deviation (100 hours). What is the probability that a bulb lasts between 900 and 1100 hours? So here x1 900, x2 is 1100, mu 1000 and sigma 100. So Z1 is what? x1 minus mu by sigma. Z2 you find x2 minus mu by sigma. Just substitute the value there. 900 minus 1000 by 100, whose value is minus 1, and this is coming 1 due to similar reason. By Z table, you need to find minus 1 less than Z less than 1. Just go through the table, its value coming approximately. This is actually, you can do this way, 2 into probability between 0 and 1. It's coming 0.6826. 2 into 3413. Yes. So required percentage will be 68.26. Hope you have understood.